All right, today we are solving system of equations, of linear equations using the elimination method, also called, aka, the addition method. Okay. You must learn all three methods, okay? This is the same thing. I think the book might call it addition. My PowerPoint calls it elimination. So our third method, our first was graphing. Our second was where we had to make a graph, but it's very time consuming and it's not always accurate. Then we did substitution. This works well if one of the variables is easy to get the variable alone, and then we can substitute. Elimination is where we basically eliminate a variable. So, I'm sorry, I'm going to take it back there. You can look really quick. Or addition method is if I'm, well, you'll see. All right. I generally like to do this when both equations have a coefficient. Both variable terms in both equations. So let's say 2x plus 3y is 5x plus 6y. I use the elimination when I have coefficients on all my variables. Does that make sense? Okay, so we take the two equations. And this is going to be really important the way you set it up because my eyes have to follow what you're doing. So I personally prefer you to write it like this. Well, we can just get started on this one. We're going to line it up where the x's line up together and the y's line up together. Okay, we have to get the x and y on all the same side, and then my constant terms line up. And then we're going to add vertically. 2x and 3x makes what? 5x. And positive y and negative y make? Nothing. 0. And 6 plus 4 equal 10. So I'm basically eliminating a variable using the additive inverses. Using the additive inverse. See the sign right there? Additive inverse is adding a positive and a negative. Yes. Sure. Okay, so now what would we do? What would we do next? Let's go, Olivier.
Divide both sides by 5.
Divide both sides by 5, and we are left with x is equal to 2. And then I go back to either original equation and substitute 2 for the x. So I'm going to take either original equation and I'm going to substitute in x for 2. 2 times 2 is 4 plus y equals 6. And so I'm going to subtract 4 and y is equal to 2. Now in this case, would I show an ordered pair? Would I show my solution as an ordered pair? Yes, because I'm given just x and y variables. There's no story to it. Questions? 2, 2. Okay. So, let's try the next one. I want you guys to try it on your own. Pause the recording and find the solution to this system by using elimination. Okay, so what am I doing first? Patrick?
So, you add the x plus 3y equals 5, and then I can add x plus y equals together.
So it's going to equal?
So, so you cancel out the x's because there's no negatives in the together.
And it equals?
0, and then there's 3 plus y equals 4y.
4y equals?
So 4y equals 5 plus 3, which is 4y equals 8.
Okay, stop there. So, 4y equals 8. Okay, next, what would I do, Jack?
What you would do is you divide 4y by 4 and 8 by 4, and you get y equals 2. And then you
Okay, what would be next, Gavin?
Next you plug 2.
We don't plug, we substitute. Everybody say it.
Substitute.
This is not an electrical plug, we substitute. Go on.
You could substitute it for negative x plus y equals 3 or x plus 3y equals 5. That I chose that one. And then I substituted it. I got x plus 3 times 2 equals 5, and then multiply 3 times 2, I got x plus 6 equals 5. Subtracted 6 from both sides, x equals negative half.
Good. And what would be the solution, Lucas, Malou?
The solution would be
Negative 1 comma 2. Questions. Now we should be able to check that. So negative 1 and 2. Does that equal negative 1 plus 6? Does that equal 5?
Yes.
Good. Negative 1, so negative 1 makes positive 1, right? And positive 2, does that make 3? Yes. So it works. Check yourself. All right, now in this situation, we can't do elimination the way it is. All right, so we can't use our elimination right now. Why? Yes, Ethan.
Because the variables aren't
We have to have the x and y on the same side. So we've got to manipulate one of those equations. What do I need to do? Yep, Ethan?
you have to subtract the 2x and then
No, I'm not subtracting 2x. I have to get x and y on the same side of the equation. Why would I subtract 2x? On the same side of the equal sign.
subtract the 3x.
Thank you. Okay? So this is what I'd like you to do. You write both originals, and if you change it, do an arrow, just like I'm doing. So I'm going to subtract 3x. It'll be minus 3x plus y. So it shows my eyes where to go. When you start doing it right here, under here, like negative 3x plus y, it makes no sense because this has nothing to do with this. Do you understand? So show me the original and show me an arrow. Is that clear? You should be writing while I'm talking, not waiting. Pen in hand. And now the other one, we're going to just keep it the same. Now I'm ready to do the elimination method. What do I do next? This Lucas.
cross out the y's.
Okay, the y's make 0. They're additive inverses. And what do I end? What's the next line going to read?
Negative x equals 9.
Negative x equals 9. Am I done? What do I have to do? Multiply both sides by negative 1, divide both sides, and x equals negative 9. Now what? Patrick? Negative 9 for? In either original equation. I like the y equals 3x. And we end up with negative 27 plus 4. Okay, which is negative 23. So our ordered pair is negative 9, comma, negative 23. And don't forget to check. Make sure it works, especially on a test. Are there any questions? Ellen?
Does it have to be negative 3x plus y equals 4? Like, can you do 2x minus y equals 5? Can you change it so it can be like y equals 3x plus 4? Maybe that 4.
We want x and y on the same side. Okay? Let's keep it consistent. Okay. Now what? I've got two equations, and now I've actually got to do some manipulation. What do you think I have to do? I have to get this. I need to get, whenever I have a plus x and minus x, does anybody know what we call those?
You call it the inverse operation? No?
Yep. Additive inverse. I'm adding the opposite. Additive inverse. So I need to manipulate one of the equations so that I have an additive inverse. How about if I manipulate the bottom one? What can I multiply it by so that I can make it, Lucas, have an additive inverse?
Lucas,
I'm sorry, Oliver.
you can multiply it by -2.
-2. I need not only a 2, but I need the opposite sign. So then I end up with, and notice I'm writing my arrow, -2x plus 4y equals -18.
Let's say y.
A1.
8.
Oh yeah, 8y. And then this one, I'm just going to rewrite the arrow, and I'm showing 2x plus 3y equals -4. And then I add, these are my additive inverses. What is my next line going to look like, Oliver?
You'll have 11y equals -22.
Okay, divide by 11, divide by 11. Y is equal to -2. Okay, if y equals -2, I can go back to x minus 4 times -2 equals x plus 8, right? That's -4 times 2, -2 equals 9, subtract 8, x equals -1, positive 1. So it's 1 comma -2 is the solution. Does that work? If this is 1 and this is -2. 2 plus -6 makes -4. 1 minus plus 8 equals 9. It works. Questions? Okay. This is very important for when I'm checking your work, that you're showing me arrows on where you want my eyes to go, because I have to understand what you're doing. Okay. Why don't you do this one on your own? Go. Pause the recording. So Trent, how about Trent? What would I do to manipulate it so that something would become an additive inverse?
So I multiply the equation 2x minus y equals 7 by, I multiplied everything by -1.
Oh, so he went -1. I would have done 5, but I'm going to do what you're doing. Did you guys do 5? I would have just done 5 because that would have made the y, but it doesn't matter. I'll show you both ways. -1, and so it became
It became -2x plus y equals -7.
and then the other one, I'm lining it up, 2x plus 5y equals 10. And so when I add them together, what do I get?
You get 6y equals 3. You divide 6 by both sides and get 1/2.
Okay. And then we use that in which equation?
I use 2x minus y equals 7.
So I'm really doing, I'm going to rename this as 14 over 2. And so what does that become? 2x equals 15 over 2. Now what? Right? Am I wrong? Am I right?
I think, yeah, you're right. It's just.
Okay, so now what am I doing?
Divide both sides by 2.
Or
Or multiply both sides by
1/2 multiplied by 1/2. That causes my x to become alone. X equals 15 over 4. So this would be 15 over 4 and 1 over 2. Yes?
I used the other equation. I got it.
Hold on. What?
I got this.
Right. So if we are, is anybody else get anything different?
Yeah. I got 3.7 times.
Okay, the equivalence in decimals, don't qualify that as something different. Did you get the right answer?
I don't
15 divided by 4 is 3.75. So you cut off, it really should be 3 3/4. So this goes 3, 12. I have a remainder of 3. I would have marked you wrong. Okay? I don't want you to round. If you need to round, go to your fractions. Okay? Now, if you see my PowerPoint did it with 5, and then we just got, as we reduced it, I got 15/4. I substituted it in, and we got y equals 1/2. All right, now this becomes the hardest kind of elimination, and that is when I have to manipulate both problems. I have to manipulate both problems. So what do you want to make the additive inverses? Do we want to make the x's or the y's? Well, how about if we go with what my PowerPoint's going with, right? They're going to manipulate what? They're manipulating the x. So when I multiply everything by 5 here, it's going to become what? Negative 10x plus 15y equals 25. And then Lucas Malou, what do I have to multiply the second sentence by? Will that make this either of those additive inverses? Okay, you're trying to get them to be additive inverses. What?
5.
No, that's not making. 5 times 2 does not make 15. Hun, you got to get a number here that's the opposite of negative 10. What is the opposite of negative 10? 2 is the opposite?
No,
10. So what do I need to multiply the whole?
by 2.
By 2. Notice I'm multiplying both equations. I'm setting out to make this negative 10. I started at negative 2x. I started at 5x. I have to multiply both equations by a different number. Okay, so we're going to now multiply that bottom equation by 2. And it becomes what, Lucas?
It becomes 10x minus 4y.
Good. And now I have additive inverses. Does that make sense? So, and now we end up with 11y equals 33. Divide both sides by 11, and y is equal to 3. Substitute in to either original, and then solve for the x. Add 6, and then divide by 5, and we get 2, and our solution is 2, 3. Questions? Please check that. Okay, that's the end of the recording. Let me see what you have for word problems. Word problems tonight are basically the same. Do you understand the word complementary?
Yeah.
I don't know how to show this on here. So some of the word problems are saying like 2 angles are complementary. What does that mean? Yes.
It means if you take the 2 angles and add them together, they add up to 90.
They add up to 90. 1 angle is 42. 2 angles are complementary. 1 angle is 42 more than half the other. So you're just doing a few of the word problems. You should be okay because it's a lot of the same of what we did last night. So that's the PowerPoint for today. Tomorrow, make sure the homework is done. It will be checked in.